Hello, my name is Steve Bowler, and in this video we're going to be taking a look at static routing. Specifically within static routing, we're going to be taking a closer look at setting up static routes on two Juniper routers. So in this lab we have router 1 and router 2, and they are joined via the LT120 interface, and this is a logical tunnel interface. In this instance we are going to create two logical systems. We're going to name the first one R1 and the second one R2. Again, this is Juniper Static Routing Lab. So if you're not familiar with logical systems, you might want to familiarize yourself with that concept. You can take a look at my logical systems labs. Logical system lab number 1, I show you how to configure logical tunnels and join two logical systems together via a logical tunnel interface. So in this lab what we're going to do, instead of having two physical routers, we're going to explain the concept of static routing on two logical routers. So everything is the same, it's just the only difference is these routers are just going to be logical routers or logical systems. So the first thing I want to do, I just want to explain a little of the network diagram, the network topology that we have. We have R1, we have a logical tunnel, as previously stated. Logical tunnel 120, unit 12 is R1 side, and R2 side is LT120, unit 21. The network between these two are the subnet between R1 and R2. It's going to be the 12.12.12.0/24 network. On R1 we're using the .1 IP address, and on R2 we are using the .2 IP address. On R1 we have the loopback 0 unit 0, and within this unit we have two subnets associated with it. We have the 1 network, the 1.1.1.0/24, and then we have the 11.11.11.0/24 network on R1. And on R2 we're going to create a loopback 0 unit 1, and you might be asking yourself, well, why not create the same, just unit 0? Well, when we're doing this on one router, as I'll show you later on, is if you try to create unit 0 on loopback 0 between two different logical systems, it's going to give you an error message. So I'll explain that more in detail later on. On interface loopback 0 unit 1 on R2 we have two IP subnets. We have the 2220/24, and then we also have the 22.22.22.0/24 network. So what I'm going to do in this lab is, at the end of this, we're going to have reachability to all the networks, and we're going to achieve this by creating static routes. On R1 we're going to create two static routes pointing to R2's subnets, the 2 network and the 22 network, and on R2 we're going to create two static routes pointing to R1's two networks, the 1 network and the 11 network. And I'm going to go ahead and, as we go through this lab, I'm going to explain some key concepts of static routing and routing in general. I'm going to give you guys a very solid foundation on how routing takes place and what exactly the router is doing when it looks up a destination subnet and how it performs its next hop functions. So let's go ahead and get started. We will go ahead and create our logical systems R1 and R2. So on R1 we're going to do the command set logical systems R1, and then we're going to use the interface LT120. Again, we're going to be using on R1, from R1's perspective, unit 12. The family is going to be iNet. Again, that's IPv4 with the IPv4 address of 12.12.12.1 with the /24 subnet mask. So also, again, if you've already seen the logical systems lab 1, you know that there's a couple more commands we have to do to bind these LT interfaces together from R1 to R2. one of the other commands is peer unit 21. So we're going to bind it to logical system R2 interface LT120 unit 21. That's the command that we do that with. And then our last command is setting the encapsulation. In this lab we'll just use Ethernet. So R1 is created as of right now. Let's go ahead and create R2 logical system. Again, the same LT interface and different units. So we're going to be using unit 21. And then again, our IP address from router 2's perspective is going to be the .2. Again, we're going to have to bind R2's logical tunnel interface to R1's logical tunnel, and we're going to do this with the peer unit 12 statement. And then our last command from R2's perspective to get the connection, I should say, between R1 and R2 is the encapsulation. Set the encapsulation to Ethernet. We'll go ahead and commit check, and then if everything works out, we'll go ahead and commit this work. Okay, so now that the commit is complete, whenever you want to go ahead and run a command from operational mode, you just put in the command run. And so I can do a run show route logical system R1. And then you can see in R1's routing table, you can see that we have two routes. We have a route to the /24 to the subnet, and then we also have the host, or the locally assigned IP address of the logical tunnel 120.12 interface. So let's go ahead and try to ping, see if we can ping across the 12 network. So we'll do the run ping logical system R1. So from R1's perspective, we're going to try to ping R2, so 12, 12, 12, 2. And you can see we have reachability across our logical tunnel. So we have the basics set up. We have router 1 and router 2's LT interface set up, and we're able to ping across it. So the next step is we're going to go ahead and now we're going to create our interfaces, our loopbacks. And these loopbacks, again, we're going to use in this lab to show you and explain the purpose of static routing on Juniper routers. So we're going to create these first on R1. We'll do set logical systems R1 interface loopback 0, and then again we're going to use unit 0. Again, the family is going to be inet with the address of 1.1.1.1. Again, this is going to be /24. So we're going to create the 1 network, and then we're also going to create the 11 network. So let's go ahead and commit this. You can see our commit has been completed. So the next thing, let's go ahead and create the interfaces that are assigned to R2, the loopback. So let's go ahead and do a set logical systems R2 interfaces loopback 0. And then again, like I said, we cannot use unit 0 again, and I'll show you that. So we'll just do family inet address. We'll just create the 2 network. Then now if we do a commit check, what you're going to see is an error that says unit 0 interface loopback 0.0 is included in more than one logical system. So it shows you're trying to set it for R2, and it's already part of R1's configuration. So that is why, if you are wondering why the loopback 0 unit 1, the logical unit 1 on R2 is being used, because you cannot do that. Oops. So we'll do the command delete. We'll go ahead and do delete logical systems R2 interfaces loopback 0 unit 0 family inet address 2.2.2.2 and then /24. So if I do a commit check, we see now that we still have the error is included, loopback 0.0 is included in more than one logical system. So if I do a show logical systems, and what this is going to show us is that R2, even though all I did with that command, that set command that I just did, the delete command, I just deleted the IP address. I didn't delete the whole loopback 0 unit 0. So the way we're going to do that is, obviously, if you've done this before, you just do a delete logical systems R2 interfaces loopback 0. And then we're going to get rid of unit 0. So now if I do a show logical systems, you can see now that it is gone on R2. So let's go ahead and create the correct interface loopback 0.1 on R2. So we'll do that by doing the command set logical systems R2 interfaces loopback 0, and then we're going to use again unit 1, the family inet with the address of 2.2.2.2 /24. So our first IP subnet is created under our logical unit 1 on loopback 0. So now let's go ahead and create the 22 network as well. We'll go ahead and commit those changes. And now we see that our commit is complete. So if I do a show logical systems, we can see now that we have all of our IP addressing completed in this lab. So if we go back to the lab, all of our IP addressing is now done. So the next thing we're going to do, and the whole reason for this lab, this is Juniper Static Routing Lab, we're going to create some static routes. We're going to create 2 static routes on R1, and then we're going to create 2 static routes on R2. So the first static route we're going to create on R1 is to the 2 network on R2. So on R1, if we go back under the top of the command hierarchy, the way I'm going to do this is with the command set logical systems R1, or let's go ahead and do this. For all of those people that are following this lab, if you're using 2 Juniper physical routers, we'll go ahead and try to make this a little more simple for you. So we'll go under, we'll do set command line interface logical systems R1. So now it's looks like we're sitting just at the command line of R1. So now we're going to create the static route from R1's perspective to get to the 2 network on R2. So we'll do that by doing the command set, and then we're going to use the routing options statement. And then if we do a question mark when we do the routing options, you can see that we have an option to create a static route. So we'll do set routing options static, and then we're going to use the last option that says route, and then it's going to ask us for our destination that we want to reach. In this case, it is the 2.2.2.0 /24. Let's go ahead and take a look at our topology just to verify that, and that is correct. 2.2.2.0 /24. So we have the command set routing options static route 2.2.2.0 /24, and then if I do a space question mark, you can see that I have a lot of options. The one that we're going to use next is what is known as the next hop. So this is where we're going to tell our router what the next hop is to reach this subnet. So our next hop from R1's perspective is going to be our exit I'm sorry, not our exit interface, the interface in which we enter into R2. That is going to be the destination, the IP address. So that's going to be the 12.12.12.2 IP address. So that is the next hop to reach the 2 network from R1's perspective. Again, that is the IP address in which we enter into R2 on. So again, if I do a question mark, we're going to use the next hop. Again, this is the next hop to the destination. And we're going to put in the value. It's going to ask us for a next hop to destination value. And then in this case, we're going to put in 12.12.12.2. Again, this is router 2's interface. Again, this is router 2's logical tunnel 120 unit 21 interface IP address. And you can see I still have more options that I can put in. I can put in more options such as retain, which is this. If I put this option on, it would always keep the route in the forwarding table. And I have a resolve, which means the allow resolution of indirectly connected next hops. So for this example, and I can also do what's called a no install. So I would not install this route into the forwarding table, but we're not going to use these for the case of this lab. We're just going to show you how to set up basic static routing. So I'm going to go ahead and hit enter. I'm going to go ahead and commit this. And as you can see, our commit is complete. So now from R1's perspective, if I do a show, now you're going to see under the configuration, you're going to see under routing options we have what is called a static route. Again, the first part of this is the subnet in which we're trying to reach, which is the 2.2.2.0/24 network, which is on R2, and we gave it the next hop of 12.12.12.2. which is correct in this case. So now from R1's perspective, if I do a run show route, we can see that we now have a static entry in our routing table pointing to the 2.2.2.0/24 network. Again, it has the route preference of 5, which is the default for static routes in a Juniper router. Again, it shows us the next hop which is 12.12.12.2, and then it gives us the interface in which the local router is using to get to the next hop. So obviously, when you're setting this up, you have to have reachability to your next hop IP address. You should be able to ping your next hop before you're even trying to put in the static route into your routing table. So now that we have this in our routing table, let's go ahead and do a ping. So we'll do, again, if you're in configuration mode, if you want to go make it look like you're in operational mode, just put in the run statement. So we'll do a run ping 2.2.2.2, and then we'll just do a rapid with a count of 1,000. And as you can see, we are successful. So let me explain to you real quick why this ping is successful. So this ping is being generated from R1, and it is using by default the exit interface, the interface in which R1 is using to reach the next hop. So in this case, this is the interface LT120 for using unit 12. So the source of our ping in this statement is 12.12.12.1. So when router 1 sends the echo requests to router 2, router 2 is able to reply to these echo requests because it knows exactly how to get to the source of the ping, which is 12.12.12.1. So what I'm going to show you next is if I do a show configuration logical systems. Okay, let's do this. We'll do a set CLI. Let's go back into router 1. If I do a set CLI logical system R1, and now if I try to do a ping 2.2.2.2 with the source of 1.1.1.1, and we'll do a rapid count of 10. Now, as you can see, these pings are unsuccessful. And the reason why these pings are unsuccessful is because we sourced these pings from our R1 network. So R1 in this case is sending an echo request to R2 with the source of R1's pings being the 1.1.1.1. So R2, when it gets these ping requests to the 2 network, if we go do this set CLI logical system R2, if we go to router 2's prompt and do a show route, we can see in router 2's routing table it has no idea on how to get to the source network. In this case, the source of the network was R1's 1 network because we sourced the pings from the 1 network. Router 2 has no idea how to reach the 1 network because obviously from router 2's perspective we have not created any static routes on R2 yet. So all R2 knows how to do in its case is to get to directly connected networks that have been properly assigned. So in this case, router 2 can ping router 1's logical tunnel interface, and that is about it. So the next step that we have to do is, if you haven't figured it out yet, is on R2 we need to create a static route pointing back to router 1's 1 network. And in order for this ping above to work, which is when we ping the 2 network and we sourced it from the 1 network. So let's go into router 2's configuration mode, and again the command to do this, to create a static route on a Juniper router, we'll do set routing options, and then if we do a question mark you can see that one of the last statements we have is static, so we'll use that, set routing options static, and then the last option we're going to use, which is route. Then if we do a question mark, it's going to ask us for the destination route in which we want to reach. So from router 2's perspective, we want to reach router 1. We want to reach router 1's 1 network. So we'll do 1.1.1.0/24, and then we'll do space question mark. And the next value we're going to use is the next hop option. So pretty much the next hop is, okay, how do I reach, telling the local router, it's telling the local router, how do I reach the 1 network? Where am I supposed to go? So we're going to tell it exactly what the next hop is. So the next hop from router 2's perspective, again if we go back to our network diagram, the next hop from router 2's perspective to reach the 1 network on router 1 is going to be router 1's LT120 unit 12 IP address. So in this case it's going to be 12.12.12.1. So let's go back to router 2. We'll give it the next hop of 12.12.12.1. Again, this is R1's LT120 unit 12 IP address. we'll go ahead and commit this change. And now we're going to go ahead and we'll go back to let's go back to R1, and we'll do the command ping 2.2.2.2. Again, we're going to source this from 1.1.1.1. We'll do a rapid count of 1000. And as you can see now, we have reachability. And again, to explain this, if we go back to our network diagram, R1's pinging R2's 2 network. So R1 is going to, again, we use the source network of 1.1.1.1, and the destination, of course, is the 2 network. So R1 sends an echo request to R2. R2 has reachability to 2 networks, so when it goes to send back this request, or I'm sorry, this reply to the request, R2 looks at the source of this ping, which was the 1 network, and it looks in its routing table to see if it has a route. So if we go back to R2 and do a show route now, you can see that we have a static route that we created that is in router 2's routing table with the address of 1.1.1.0/24, and it shows the exit IP address, which is 12.12.12.1. I'm sorry, that's not the exit IP address, that's the next hop IP address, and it shows us the interface to reach this next hop, which is the tunnel on R2. So R2 obviously sends the reply back to R1. R1 gets it, and as you can see up here, we had reachability. So the next thing we're going to do, let's go ahead and finish this off. We'll go ahead and create the static routes to the 11 network and the 22 network. But also what I want to show you is, I just want to show you a quick option that you can use just to show you kind of what the router's doing. Let's just do a trace option. We're going to do this from R1. And if you're not familiar with trace options, you can go ahead and take a look at I have a lab that shows you the basic functions of trace options, and that's trace options lab number 1. And how we're going to set up trace options for static routes is I'm going to go under set logical systems. Again, on R1 we're going to set up a trace option. So set logical systems R1 routing options, because that's where we find the static routing. And then we have our last option, which is trace options. And then we're going to name our trace options file. We'll just name this, we'll call it static route. And then now that we created our file, we have to tell what we want to flag, what events we want to see. So we're just going to do route and then hit enter. So we'll go ahead and commit this statement, and to view this trace option file, we'll just do the command run show log, and for a logical system we have to put in our logical system, which is R1, and then you can see we named it the name of static route. So this is how we're going to look at our trace option file on R1, on R1's logical system. I'm sorry, on the logical system named R1. So you're probably wondering, why am I doing all this? Well, I want to show you, if we go to R1, we'll do this. We'll do set logical systems R1, routing options, static, route, and then we're going to create a static route to router 2, which is the 22 network. And we're going to give it the next hop of 12.12.12.2. Again, that's router 2's interface IP address, the logical tunnel. And that should be it. So let's go ahead and commit this. And we can see that we have added the route, and we are seeing this in the kernel table request. We are seeing this actually being added into our routing table in somewhat real time. Again, this is the route to the 22.22.22.0, and its next hop type is unicast. So this is pretty cool stuff. We can see that we added this in. You can see that we have a change made with the gateway 12.12.12.2 static preference and the interface in which it's going to forward this traffic out to reach the 22 network. So this is how we use the trace option. I just wanted to show you this simple function on how to create a trace option file for your static routes. So now if I do a show logical system R1, you can see where we created this trace option function. So we went under the routing options, the trace options, created the file named static route, and we flagged the routes. Once we did that, when we added that static route and did the commit on the router, we saw some changes made, and we saw that the routing table, the forwarding information base, got updated with the new route to the 22 network. Okay, so the next thing we want to do is, if we do let's do this run show route logical system R1. We can see now that we have the 22 network, we have the static route pointing to the 22 network. So let's go ahead and do this. We'll do a run ping logical system R1 to the 22 network, and you can see that we have reachability. However, if we try to do a run ping to this and source this from our 11 network, you can see that we do not have reachability. And again, this is because router 2 does not have the path back. It does not have a static route. We do not have a static route built on R2 pointing back towards R1's 11 network. So when R2 goes to send this traffic back to R1, well, it doesn't know to send the traffic back to R1, because R2, again, if we looked in router 2's routing table, it does not have a route back to the 11 network. So as you might see, the next thing we're going to do excuse me, the next thing that we're going to do is we're going to create a static route. So we'll do set logical systems R2. I can show you how to do this. Again, we'll go ahead and let's do this. We'll do this like we're sitting at router 2's command prompt. We'll do set CLI logical system R2, and then we'll go into configuration mode on R2, and we'll do the command set routing options static route, and again it's going to ask us for the destination. So we're going to put in the 11 network, Again, that's /24. And then we're going to put in our next hop of 12.12.12.1. Again, this is R1's LT120 Unit 12 IP address as the next hop. So we'll do a commit and quit. And now on R2, if I go ahead and do a show route, you can see that we have reachability to the 22 network. So now if we go ahead and let's do this. Let's do set CLI logical system R1, and from R1, if we're sitting at R1, if I do a ping to the 22 network, so ping 22, 22, 22, 22, and we're going to source this from our 11 network. Then we're going to do a rapid with a count of 1000. And now you can see that we have reachability. So that is it. That is the basics of static routing and how to set it up on a Juniper router. Again, to summarize what we did, we created two static routes on R1 pointing to the 2 network and the 22 network on R2. And then we created two static routes on R2 pointing towards the 1 network and the 11 network on R1. Also, as a added bonus feature, I went ahead and on R1 I created a trace option which logged some of the routes that were added to our routing table, and we saw that in real time when we went in on R1 and created the static route to the 22 network. We're able to use the trace options function and see where the 22 network was actually added into the routing table on R1. So thanks for watching the video, and I hope to see you in the next one.